Hello everybody, welcome to the channel World of Cell Planning. I am Mahesh here. Today in this practical we are going to see practically KCL. You heard that name many a times. We are going to do the practical of the KCL theorem, Kirchhoff's current law. Yes, you heard it correctly. We are going to do that practically. Yes. So today's agenda for a practical. So first we will see and build the circuit on the software, see the simulation and then directly go to the workbench for a practical. So let's start with the simulation. Now you can see on your screen I have opened an Multisim software in which I have built a small circuit. We are having a 5 volt power supply in our circuit. Also we are having a 2 resistors of each 1 kilo ohms placed up parallelly because we are going to see the Kirchhoff's current law and KCL applies where nodes are there. So for creating nodes we have made these parallel connections. Let's see some terms used here. We have named our voltage supply as V1. Then this is I total, which will be the total current flowing in our circuit. Then this is I1 current flowing through resistor R1, I2 current flowing through resistor R2. This is our digital multimeters. So let's start with the practical. So before we measure anything, we have to calculate a theoretical values. I have calculated here. I will explain it briefly. So these two are connected in parallel. So we know when the resistors are connected in parallel, we get equivalent resistor formula like this: R1 into R2 divided by R1 plus R2. Yes. When we put this value inside this formula, we get a equivalent resistance of 0.5 kilo ohms. Yes. Then the total current flowing in the circuit will becomes voltage divided by R equivalent. That will be 5 divided by 0.5 kilo ohms. It will be 10 milliamps. It will be 10 milliamps. Okay. So we know the total current flowing in the circuit will be 10 milliamps. Then what our Kirchhoff's current law says? Algebraic sum of all the currents at a node will be 0. Means what? Current incoming to the node will be equals to the current outgoing from the node. So here the incoming current to the node, this is our node. Incoming current to the node is I total and outgoing currents are I1 and I2. So our KCL will state us that I total will be I1 plus I2. So let's see them theoretically first. We will measure them practically. So I1 will be what? It will be V1 divided by R1. So here it is voltage across this R1 is what? Both are connected in parallel. So voltage will be 5 volts. So 5 volts divided by what is the resistance value? It's 1 kilo ohm. So we get the current flowing through the resistor R1 as 5 divided by 1, 5 milliamps. Similarly, for R2 having same value, so we will get a same current, that is 5 milliamps. So theoretically our KCL is verified here because I total is 10 milliamps and we get I1 and I2 both 5 milliamps. So our KCL theoretically verified. So now we'll run the simulation and see whether it is verified or not. So I am here having a multimeter. We will measure current flowing through each resistance. So now I will broaden the circuit. Okay. For measuring the current, if you don't know how to measure the current, then see the video showing in the I button. So you will get more clarified. We have done a separate practical for how to measure the current and the voltage in the circuits. So let's start. For measuring the current, we have to place the multimeter in series with the component. So here our first component is R1. So we delete this wire, and for measuring current we have to connect the multimeter in series with the component. So let's connect it with series. So its positive terminal should go to the power supply and negative terminal should meet to the resistor. So you can see I have connected the multimeter in series. The incoming power line, one end goes to the multimeter and second end goes to the resistor. So we'll now run the simulation and see what current we get. You can see the current flowing through a resistor R1, that is I1, is 5 milliamps. Similarly, we will measure it for I2. I will delete this component. Now I have connected our multimeter in series with the resistor R2. So to measure the current through it. So I will run the simulation. We'll now see the current is 5 milliamps. Again 5 milliamps because both resistors are of the same value and we got that theoretically 5 milliamps. We have done with our simulation. Now we'll go to the practical workbench and see there practically how to build this circuit, how to measure the current and voltages and verify our KCL. So let's go to the workbench.
Hello friends, welcome to the workbench. We are now going to practically verifying the Kirchhoff's current law. We have seen the simulation and build the circuit there. Similar circuit we have built on our breadboard. Okay, you can see both the resistor of 1 kilo ohms connected with each other in a parallel fashion. You can see this is the parallel fashion, two wire connected both of ends and two wires running to the power supply. You can see this is a negative wire, this is a positive wire, and the power supply is of 5 volts. I will show you. You can see it's a 5 volt. 4.98 means it's a 5 volt power supply. So now let's check whether what is the total current flowing in our circuits. We have calculated that current theoretically and we got about 10 milliamps. Let's check whether our power supply is giving 10 milliamps or not. I will remove this wire. You can see I have removed this wire. For measuring current, we have to put multimeter in series. If you don't know how to measure the current, then go and see our video which is in I button. There we have taken a separate practical on how to measure the currents. I will put that wire here, so there will be no connection in the circuit now. For measuring current, I will touch one probe of multimeter to the power supply range and another to the circuit. So now we'll get a current in our circuit. First we have to set it to the amps mode. I will set it to the amps mode. What we got? About 10 milliamps. So I will put it in the range of 20 milliamps. Now I will put one end of the multimeter to the power supply range and another to our circuit range. So we will get a current. Now you can see we are getting the current of 9.8283. Okay, means around close to 10 milliamps. Due to the resistor tolerance, it will vary, but we are getting an approximate 9.84 around. Okay. Now we'll plug that back to the power supply and we'll see individual currents. Okay, now our circuit becomes as previous was. Now we have to measure the current across this resistor, okay, this 1K. So what we have to do? We have to put a multimeter in series with it. So we will remove this wire and put a multimeter here. So let's remove it. I have put that wire in two holes apart, so there will be no connection in the circuit now, because you can see this hole is, these both are not connected, so our circuit is broken now. We will place one end of our multimeter to the resistor and another to the wire, so they will complete our circuit. Now you can see I am putting one end to our wire and another end to our, okay, we are getting the current of 4 point, it's fluctuating but around 4.8, okay, 4.8. So we got a current about 9.8, so it's closely to the 5 milliamps. As we theoretically see that both resistor will carry a 5 milliamps of current through them. So we are getting first resistor carrying 4.8 and that is closely to the 5 milliamps. Let's check for another resistor as well. We have to make the circuit as previous before unplugging the another wire. Okay. Now we have make the circuit as previous and we have break this connection, so there will be no connection for resistor 2 and a power line. So we'll measure the current flowing through the resistor 2 now. You can see we are getting a current of 4.95. okay, it's fluctuating. I will show you once again. You can see we are getting current about 4.9. okay, that's very closely to the our 5 milliamps. So the current flowing to the resistor is 5 milliamps and also flowing through this is also 5 milliamps. So total current becomes 10 milliamps and we have verified our KCL law here. KCL states that the incoming current should be equals to outgoing current. So our incoming current previously from supply was 10 milliamps and it gets divided into resistors such that follows KCL. We have done the practical of KCL.
That's all for today's practical. We have seen practically the KCL theorem, which is Kirchhoff's current law. How it works, okay? One announcement here. We have made a practical crash course electronic on our channel World of Cell Planning. So I request you to visit that playlist. You will find many more such interesting practical videos there. So you can see the playlist in the right hand side. You can click on that and you will go directly to the course. So we will meet a day after tomorrow with a new video, the new practical, new concept. So stay tuned for the next video. So goodbye.